Yes, students, last time I asked you to try this question and we are back on that. How do you get this question? We are supposed to determine the acceleration due to gravity at a height of 1,200 kilometers. We are given the radius of the Earth to be 6.4 times 10 exponent 6. And we are also given acceleration due to gravity change to be 9.81 meters per second squared. So how do we do this question? It's very interesting and very simple. Okay. So let me create my new board. I hope you can see my new board. So solution. We are asked to find acceleration due to gravity at a certain height. All right. Acceleration due to gravity at a certain height. And we are given the change to be 9.81. Last time, this was the formula, if you recall, this was the formula we ended on. We said that when the body is at a certain height above the Earth's surface, let's see if this is the Earth and this is the body above. What we said is that if this is the height above the Earth's surface and this is the radius of the Earth, then we said our G is what? It's Gm over what? R plus H all squared. That's what we said. Good. So what are we trying to do? The question didn't give you the universal gravitational constant, neither did it give you the mass of the Earth, though they are constant. So in this case, I will encourage that you don't go near them, applying them there. Okay. The question has given us you can decide not to cancel. If you have written these things, don't cancel. But I was just using it to demonstrate something to you at the height. So we want acceleration due to gravity. Let's call that at a certain height. So let's call that 1 GH. Okay. Just to differentiate, we are using G. Don't get confused. We are using it to differentiate between the gene he gave us because the question gave us another gene. And it says the height H is what? 1,200 kilometers. According to the question. Check the question. 1,200 kilometers. Okay. And we are given the radius of the Earth. Denoted by capital R. 6.4 times 10 exponent 6 meters. Okay. Yeah. And we are giving small chain. We are giving small chain to be 9.81 meters per second squared. Right. So what do? We know that how do we get GH? GH will be what? Gm over R plus H all squared. but we weren't giving Gm and G and capital M. But you know that we proved in our early lessons that Gm is equal to Gr squared. I hope you remember this formula. So then we can now see that Gh will be Gr squared, okay, R plus H all squared. Since the question gave us only the G's and the R's. Exactly. Yeah. So what do we do here? We fix in the values. This is 9.81 and our R is what? 6.4 times 10 exponent what? 6 all squared all over. I would advise you that you convert this one. When you are multiplying, it wouldn't be a problem, but when you are adding, it depends on you how you present it. Plus what? H 1002. Look at your G. Your G is in, our G is in meter per second squared. Our R is in meters. We have to convert our H as well. So when we convert our H, it's going to be 1200. Kilo is 10 exponent 3 meters. So that here I'll get 1200 times 10 exponent 3. And I square all these. Exactly. So that, what do we get? We continue on our next page. Okay. Here you have to be very careful how you enter it. I will advise you that you break them before you continue. Okay. You break the powers into ordinary numbers. Otherwise, it is going to give you a problem in your final answer. So solution, okay, we have a GH is equal to, this is what we have. What do we get for the numerator? Let's check. The whole of the numerator gives us what? 9.81 times, then you open your bracket, 6.4 times 10 exponent 6 all squared. This is what I had. You are going to get 4.018176 times 10 exponent 14 all over. Okay, that will be for the numerator. Let's check this. When you convert 6.4 times 10 exponent 6 to ordinary number, you get this. This is what you get. Because if you don't do it that way, and you enter it on the calculator, you may have issues. The calculator may give you the wrong value. And when you convert 1200 times 10 exponent 3 to ordinary number, this is what you are going to get. And here we are adding. So 3 zeros will come and add to it. And it's all squared. And the whole of the denominator will give you. So you see, this one becomes easy to enter on the calculator. So we get 4.018176 times 10 exponent 14. Let's try and enter everything in the denominator. Let's square it and add on and see what we get. The whole of this is going to give me 5 point. Please verify with your calculators. 13. And when you divide this, you are going to get you are going to get 6.957 meters per second squared to 3 decimal places. Okay. So how do we conclude? So we say that therefore, hence, the acceleration, okay, due to gravity at the height of 1,200 kilometers, that is what the question said, is 6.957 meters per second squared. So this equation tells you that when you look at the equation, when you check this equation, the body no air far from the earth, with acceleration due to gravity, no, what square, the man is aseɛ no bɛyɛ kɛseɛ, ɛno square aseɛ na ase no bɛyɛ kɛseɛ more, na ase no bɛyɛ kɛseɛ a hye no bɛyɛ ketewa. So what it means is that the fact that you move, acceleration due to gravity reduces. It reduces. That's why those two to space at a certain point when you get to some of the planets, the pool is very, very large. Yeah. So it decreases. The change decreases with height. All right. I hope you are okay. Thank you. So try this question on your own. Use the understanding you have acquired here to work this. The most important thing is the conversion. And when you are working with the standard forms. All right. Thank you.